Okay, so I'm going to go through 30, 60, 90 triangles today with our specials. This will look very similar to what you saw yesterday. Again, a 30, 60, 90, what we mean when we say that is that we have a triangle with a 30-degree angle, a 60-degree angle, and one 90-degree angle. This right here, as I mentioned today, is our base form. And this base form of a 30, 60, 90 triangle allows us to set up our ratios. A little difference between these and 45, 45, 90 is that I'm going to have a short leg and a long leg. Looking at this, again, my hypotenuse is still directly across from a right angle, but this time the 30-degree angle, the side across from it is going to be my short leg. And I used the hand example today in class. Looking across from the 60-degree angle, that's going to be my long leg. Because the 60-degree angle has to open more to create that angle. So the distance, again, I used my hands between my fingers, is going to be a greater distance. I will probably not write short leg and long leg today. I'm probably going to use an abbreviation. For today, short leg is going to be represented by SL. Long leg, I'm going to use LL to represent that. Looking at these ratios, the first one says, what is the ratio of the hypotenuse to the short leg? Hypotenuse is 2, and the short leg is 1. In other words, this ratio is telling us that the hypotenuse is twice the length of the short leg. And we're going to use that info in just a second to set up an equation. Looking at the next one. What is the ratio of the short leg to the long leg? Well, in our base form, the short leg is 1, and the long leg is square root 3. From this, we can make some determinations that actually the long leg is equal to the short leg times square root 3. This one right here is actually very close to an equation, and I'll show you what it looks like in the next slide. The last one is looking at the hypotenuse and comparing it to the longer leg. The hypotenuse in this problem is 2 in our base form, and the longer leg is square root 3. This is telling us some useful information. And in class, we went through how this ratio could also be used. But for us today, I believe I'm just going to stick with this ratio and this one, and using those two to set up two separate equations. Looking at the next slide, the two equations I can set up are right here. Here's the first one and the second one, using the first ratio and the second ratio. And again, I just copied our base form onto this slide as well. So using this to actually solve equations, excuse me, using this to solve special right triangle problems, looking at our first example, first thing I want to do is establish, is this actually a special right triangle? Well, I know that this angle right here is actually 60 degrees. How do I know that? Well, all angles in a triangle should add up to 180 degrees. And I know that one angle in this one is 90, minus subtract out the other one 30, it must be 60 degrees. I also want to label my different parts on this right triangle. I've got the hypotenuse. Across from the 60 degree angle right here, I've got the long leg. Across from the 30 degree angle, I've got the short leg. So I'm going to start with one of my equations. I need to find the short leg first, because if you look at both equations, both of them involve knowing the short leg. I'm going to use the first equation that says the hypotenuse is equal to the short leg times 2. My hypotenuse right now is 12, equal to the short leg is y times 2. If this bothers you, you can rewrite that to be 12 equal to 2y. Solving this equation, divide both sides by 2, you get y is 6. Looking at figuring out what the long leg is, I need the second equation, which says the long leg is equal to the short leg times square root 3. The long leg value in this problem is x. The short leg I now know is 6 times square root 3. There's actually no work to do because x is already isolated by itself on one side of this equation. So my long leg is 6 square root 3, my short leg is 6. Looking at another problem. Again, I need to establish, is this actually a 30, 60, 90 triangle? Using the same logic as the previous problem, I can determine that that topmost angle, this one, is indeed a 30-degree angle. Leveling off my parts in this right triangle, I've got my hypotenuse, the long leg, short leg. Working with the two equations that I know, I need to find the hypotenuse. And I do have the short leg at 6, so I'm going to use the first equation, hypotenuse equal to short leg times 2. The hypotenuse is x, the short leg is 6 times 2. Doing the multiplication, you get 12 for my short leg. Looking at the long leg equation, it's equal to the short leg times square root 3. Well, I now know that my short leg, and it gave it to me in the problem, is 6, so plugging in, the long leg is y, my short leg is 6 square root 3. No work to do here on this one, because y is already isolated and on one side of my equation. Looking at the last example, it says a skateboard ramp must be set up to rise from the ground at 30 degrees. There's my 30-degree angle. If the height from the ground to the platform is 8 feet, I know that one's hard to see, 8 feet. So here's the platform. And this side I know right here is 8 feet. So now it looks like I've got a right triangle situation going here. And we're assuming that the platform itself is perfectly straight. I know that this other angle up here is 60 degrees from my same logic as before. And it wants to know how far away from the platform must the ramp be set. So it's wanting to know this distance right here. Well, that's going to be my long leg. And just because we're continuing to practice, I'm going to find my hypotenuse, which is going to be how long is this ramp? So I'm going to, at the end of this, knowing my hypotenuse, how long is the ramp and how far away from the platform does this ramp need to be to ensure that I do in fact have that 30-degree angle. Looking at this problem, first thing I think I'm going to find here is my hypotenuse, which is equal to the short leg times 2. My hypotenuse, I'm just going to pick a variable here. I'm going to pick x. The short leg is 8 times 2 is 16. So the ramp itself is 16 feet. Finding the long leg, I'm going to use this equation, long leg equal to short leg times square root 3. My long leg here, again I don't know, just pick a variable. I'm going to pick y. My short leg is 8, no work to do, square root 3. So looking at this, the distance I need to place it from the platform all the way out is going to be 8 square root 3 feet. Now again, this is a realistic kind of problem. It would be kind of weird to walk up to someone and say 8 square root 3 feet. So I think I'm going to use my Inspire, and I'm going to do 8 square root 3, hit enter, and I think I'm going to round this one off. Rounding it off, it would be about 13.9 feet, which I think might be a better way to say it. If you put this, I'm certainly not going to count it wrong for this example, but since it is a realistic type of problem, you may want to round.